Hello, everyone, and welcome to our first episode of Some Good Science. Some Good Science is inspired by Some Good News, hosted by John Krasinski. You may recognize him as this guy, from a very popular TV show called, well, you know. Today's topic is part 2 of Climate Factors and is hosted by yours truly, Mrs. Scott. You think I'm kidding? Not. 20 years. So let's get started. Today we're all wishing we were someplace different, whether it's Miami, Florida, Los Angeles, California, Denver, Colorado, or how about Bismarck, North Dakota? All these places are very different because they have different climates. Climate is affected by a variety of things. Yesterday we talked about 3 of them. Latitude and elevation, as those increase, the temperature will decrease. It'll get colder. That affects the temperature. Also, we talked about orographic effect. Orographic effect affects the amount of moisture in an area. If you live on the windward side of a mountain, where you get a lot of wind, picking up a lot of moisture from a large body of water, then your climate's going to be more humid. If you live on the opposite side, on the leeward side, away from the wind and moisture, then your climate will be more arid and drier. Today, we're going to talk about the next 3 factors. Factor number 4 is closeness to large bodies of water. Take a look at this picture of California. If you live along the coast, temperatures stay pretty much moderate or even all year long. If you live more inland, further away from a large body of water, your temperatures will be more extreme. These temperatures taken in these areas are taken at the same time of year, almost closer to the summertime. Sure, temperatures will increase for all areas in the summertime and cool down in the wintertime, but pretty much if you live along the coast of California, your temperatures will stay cooler most of the year. From January to December, they stay pretty much even and moderate. Whereas if you live further away from the water, your temperatures are going to extreme and vary a lot more from January to December, getting really hot. These temperatures here in the Inland Valley can reach like 100 degrees plus easily in the deepest part of the summer months. If we were to graph the temperature and moisture of some areas, such as Reykjavik, Iceland, or Yakutsk, Russia, you could see that their climates are very different. Reykjavik, Iceland is surrounded by water. They're both the same latitude also. The temperatures here are measured in Celsius, and that is connected with the line graph from January to December. Down here at the bottom, the bar graph represents the amount of moisture in centimeters throughout the year also. Now compare the line graph and the bar graph for the temperature and moisture to Yakutsk, Russia. And you can see it, like I said, the latitude is pretty much the same. Okay? The difference is their location from a large body, or their distance from a large body of water. So the temperature range is more even, more moderate for areas that are closer to a large body of water compared to areas that are further away, that you could see that's an extreme temperature variation from January to December. Also, if you're not near a source of water, then you're not going to get a lot of precipitation usually either. Okay. Climate is very different for those regions. So if we were to show you another bar graph, pick city A or pick city B, you could tell which one is close to a large body of water without me even showing you it on a map. Okay? And you could see that B is closer to a large body of water because the temperature is more, throughout the year, is more moderate. The line graph is flatter. Whereas again, you could see that the temperature graph for city A is more extreme. There's no precipitation indicated in this whatsoever. So if we wanted to just talk about how is the temperature affected, you'd say that water moderates the temperature, making it cooler summers and warmer winters. Okay, a couple other factors that we want to finish up with are wind belts and ocean currents. Wind belts affect ocean currents, but we're going to talk about wind belts first, okay? So wind belts occur only in the troposphere. And if you're at latitudes 0 degrees, the equator, and 60 degrees north and south, then your climate's going to be wetter. It's going to be more humid. And usually there's lower pressure indicated at those areas. And that's because you have winds converging, like large wind belts converging together. When that happens and they converge, and then it causes uplift and it creates clouds then, and creating more moisture in the air and precipitation. So you know that a lot of our rainforest forest environments are located along the equator. And so then that makes sense. Whereas your arid climates, and check it out on a map too, a lot of like the Sahara Desert is close to like 30 degrees north latitude. And those areas are very arid, and because there's a lot of high pressure, because what happens is that the air pressure moves downward and it's very heavy and then diverges away at the surface, and therefore creating more arid conditions. Clouds can't then form if there's a lot of pressure pressing down on the surface. And on our reference table, page 14, there's a diagram that we didn't talk about earlier in the year. And it basically says that the planetary wind and moisture belts in the troposphere, the drawing is going to show locations of the belts near the time of an equinox. So we're not talking about like the summer or the winter, which is, equinox. And the locations of these arrows will shift either toward the north or towards the south, depending on the season, summer solstice or the winter solstice. So right here, you could see that 0 degrees is the latitude for the equator. And you could see that it says it's very wet here. And if you look at these arrows on the inside of the circle, just focus on the arrows on the inside of the circle, because that represents the wind on the surface. So you can see that they're moving towards each other. So when they're moving towards each other, that's converging. And then now follow these arrows over here. Because they're converging, then it's allowing uplift, all right? And allowing clouds then to form, creating then humid conditions. So these arrows on the outside of the circle represent rising air away from the surface. So check that out. Now, it's also, well, let's just stick with 30 degrees north then. 30 degrees north, you can see is the opposite. And you could see at 30 degrees north, the arrows are moving away from each other. So they're diverging away from each other at the surface. And as they diverge away, now come over here and look outside of the surface of the Earth, or above the surface, and you can see that the arrows are moving down, showing sinking air. When you have sinking air, it's high pressure then. You could also see it's happening here at 30 degrees south, which is where Australia is located. So you have diverging air and you have sinking air, okay? Diverging at the surface and sinking towards the surface. So you'll have a lot of sunny conditions here, dry climates, and the equator, you'll have the opposite. If we were taking notes, we would write that down. Air is rising at the equator. Air is sinking at 30 degrees north. So if I were to ask you what are some differences, you can name me a bunch of them between 0 degrees and 30 degrees north. Some of the differences you could say is 0 degrees is wet, 30 degrees is dry. You could say 0 degrees, the winds are converging and rising, and at 30 degrees north or 30 degrees south, you could say they are diverging and sinking. Hope I said that right. Ocean currents. Ocean currents are affected by wind belts. As the Earth spins, you got the Coriolis effect. You've got your wind belts and ocean currents moving towards the right in the northern hemisphere and moving towards the left in the southern hemisphere. But I think the best thing or the coolest thing about your ocean currents is that they're going to affect the climate of a region depending on like the temperature of the ocean current. So take a look over here. If you remember that in the northern Atlantic Ocean, there's the Gulf Stream. New York is right about here. And remember that it's a black arrow. So it's a warm current, right? It's not as warm as down here. It's a north equatorial current, but it moves in this direction and it's still warm. And because it's warm, it still continues to go in this direction. You can see that this arrow is definitely directly affecting England's climate. Okay, so even though that London, let's say for example, is a further or a higher latitude than New York, its climates rarely ever get any snow because those warm currents will create warmer temperatures. And if temperature's too warm, then you can't get a lot of snow. Over here, if you look at California, you got the California current, okay, and it's moving away from the poles. And because it's moving away from the poles, it's a cool current, which is good because if you have Los Angeles, which is down here, much more south than us, gets more direct sunlight, gets pretty hot, but its temperatures are cooled down because of that cool California current. Now check this out. Let's go back to the Gulf Stream. Okay, you can actually, this is a surface temperature map of the Atlantic Ocean. And you can just see that this is the Gulf Stream right there. It kind of eddies off a little bit, you know. Right over here, this is Long Island. And hurricanes love to feed off of this warm water. And most of them usually get bumped off of the coast and just continue to move in the same direction as the wind belts and the ocean currents. So that's why a lot of them will steer towards this direction. But of course, that's why we keep an eye out for them. And we'll talk about hurricanes more when we get into our weather.